Well, welcome back to our room. As you can see, we've made a bit of progress. Over here, we've drywalled the Helmholtz resonators in both corners, and actually in all four corners. And one of the side benefits of putting these walls up in the drywall is that the slap echo in the room has changed dramatically. I don't know if you remember, but in our earlier video, the slap echo was pretty bad. It had a long decay, and these non-parallel surfaces that we've put into the corners have really eradicated that slap echo. So that's a really good thing. And our plan on these Helmholtz resonators, you can see up here where we've mudded around it, is to punch a hole up into the top part of the frame. Into that hole we'll be placing our tuning port, and if you'll recall, that port is going to select the frequency, which if I remember right, I think it's 27 hertz that we're trying to get rid of. And we'll also be able to control not only the frequency but the Q. So the Q is how narrow the bandwidth is that we're trying to solve. So if it was 27 hertz and broader, then we could control that Q by shortening the length of the port that we build into the Helmholtz resonator. So shorter port length, then we have a broader Q. So that means that we will encompass more frequencies around the center point of 27 hertz. If we need a very narrow Q, or a high Q, and a very narrow frequency, we'll extend the length of the port in order to narrow up the area that we're trying to eliminate in the Helmholtz resonator. Another thing that we're going to be doing, as you know, is to absorb the energy in here. We need to put damping material. That damping material is going to come in through a hole in the top, and we're going to go down to Home Depot and rent one of those acoustic insulating things. Hey Ron, good morning.
Morning, how we doing?
We're doing great. We're letting everybody know what's going on.
All right.
All right, so Ron's in the middle of adding all the mud up here. So we're going to buy one or rent one of those acoustic insulating blowers, and we're going to blow the insulation into the top up here, which will fill this cavity, and the amount of damping that we want, the elimination of those frequencies, will be dependent on how much we put in there. So it'll be a combination of how much damping material, the size of the hole, which determines the frequency, the length of the port that controls the Q. And that will happen to all four of these corners. You might also notice that there's a big hole over here. There's another one over there, and this is where we've put an area so we can mount the CD rack into the wall. And on the left side, we have the area where we're going to have our vinyl. So vinyl will go on the left, and that's a very deep hole. CDs on the right, where we'll have up to 1,000 CDs if we want for our library. One of the problems I wanted to mention that we had in the original sound room was a plethora of cables. So over here, if you remember, we had all of our equipment, and we had a 20 or 30 foot long XLR cable that went over here to the back, fed the power amps, and then we wired off of those cables to our subwoofers through a little box that I'd made. And in general, it was a pretty good mess. They were laying on the floor. We then got cable lifts and brought them up off the floor, and that helped a little bit. But I never really wanted to have that mess. And now that we've been able to figure out a way to get all of the equipment off the floor, I want to keep the cables off the floor as well. So, you know, we built this room where we're putting in all of the equipment, and we'll show you that when we build the rack that Ron's working in now. But how do I get the sound out of here? I don't want to run a bunch of cables along the floor like we did before. And that has brought up an entire debate in the engineering department, how we're going to do that, because this is a reference room. We do need to make sure that whatever we do doesn't have too much of an effect on the sound, so that we can A/B products, we can do everything we need without having to worry too much about how it's going to sound, how it connects up. So what we've done is, after a lot of debate, we've figured out that down here in the corner, actually right over there, we've put a box and a pipe that goes up the ceiling, goes over the top of the warehouse where this room is built, and down here into this port. So what we're going to do is put 4 XLR connectors there and 4 XLR connectors here. There will be 2 separate runs of cable that go up over here. It's about a 50-foot run down through the pipe and extend out over here. And those runs of cable are going to be, after a lot of discussion, Mogami wire. If you're familiar with Mogami, they have a number of different types of wire. This is what a lot of studios are wired with. And they've got a balanced XLR cable that I've used before, pretty neutral in sound quality. Could we do better? Yeah, but our goal on this is to have as neutral a cable as we possibly can. As my friend Bill Lowe of AudioQuest would say, we want to do as little damage as possible without adding any kind of sound, and make it practical. So we've got 4 runs of Mogami wire going up over the ceiling, down here, and into our box. From here, I'll have XLR connectors that I can then put any cable I want into the power amplifier and to the subwoofer amplifier. For those areas, we'll have the big tower standing here. Each of the IRS woofer towers has I think it's a couple 1,000-watt servo amplifier. So we'll have individual P10 power plants, one here, another one here, and another one here on little stands, each going into their dedicated line through these outlets that we've wired in a dedicated fashion back to the circuit box. And those will each feed a P10 power plant. Each power plant will then feed a single tower, and the one in the middle is going to feed the power amplifier, our new perfect wave power amplifier that we're coming out with. So you've got 3 P10s sitting on racks, feeding the entire system, and it should be a pretty neat install. A couple other points of interest. We're going to wait on building the Helmholtz resonators into the ceiling until we get this whole thing textured and painted, and then they're going to pop a hole into that. That's our chief engineer's decision. I don't understand all that, but that's okay. That makes it easy. And one last area is the ceilings. Now originally, I was going to take a couple of long headers and put them down here where the lights are. If you can see where the lights are going in a row, there's a space of about 8 feet between here. We were going to run 2 long headers, and then we were going to place some roofing material that would create a curve. You might see this stuff as kind of flexible, rippled roofing material. That was going to be our plan, and we were going to make these curves up here that allowed us to have non-parallel surfaces between the floor and the ceiling, which would have helped a lot. If you've ever been to Lyric Hi-Fi in New York, you might have seen such a ceiling. They've got a really beautiful ceiling with slats that go into this curved area. And we were going to try and duplicate that, but the fact is we're running out of time on this. And as any project that you may have been associated with, it goes over time, over budget, and here we are. So we made the decision, all right, we can always add something later up to the ceiling, but it's time to get the big IRSs in here and get this room back into operation. So that's the plan. This weekend we'll be sanding, texturing, and getting ready for paint, which should happen in the middle of next week. Carpet goes in the week after, and then we move in the big IRSs. Should be fun. Thanks.